Now, in this lecture, we'll answer on two questions. In the first question, we'll find out the area of this square ABCD. In the second question, we'll find out the size of this angle theta. Okay, we start with the first question. In the drawing, we have square ABCD. We know that line segment AB equals to 5 units, line segment PB equals to 3 units, and line segment PC equals to 6 units, and our mission is to find out the area of this square ABCD. So first of all, we'll make a construction. We'll extend side DC of the square by a straight line. And from point P, we draw perpendicular on the extended DC. So this angle equals to 90 degrees, and this angle will be also equal to 90 degrees according to our construction. We define the touching point of the perpendicular from point P at the extended DC as point N, and here from point B, this point we draw perpendicular on Pn. Again from point B, we draw perpendicular on Pn. So here this angle equals to 90 degrees, and this angle will be also equal to 90 degrees according to our construction. We will define the touching point of the perpendicular from point B and Pn as T. Okay, so we know that all the angles inside a square are right angles. So here in this square ABCD, we have 4 right angles. This angle equals to 90 degrees, this angle equals to 90 degrees. This angle, it is also equal to 90 degrees, and finally this angle is equal to 90 degrees. We know that DC is one side of square ABCD, therefore it is absolutely a straight line. And when we extended the straight line DC by a straight line, the result is dn. When you extend the straight line by a straight line, the result must be a straight line. So dn is also a straight line. So if we focus on the upper side of the straight line dn at point C, here the sum of the angles must be equal to 180 degrees. According to rule number 3, that the sum of the angles on one side of a straight line is equal to 180 degrees. So the sum of the angles on the upper side of the straight line dn at point C must be equal to 180 degrees according to rule number 3. So if this angle equals to 90 degrees, the missing angle must be also equal to 90 degrees in order to complete the sum of the angles on the upper side of the straight line dn at point C to 180 degrees. This angle must be equal to 90 degrees. So in quadrilateral BTCN, we have 1, 2, 3 right angles. The sum of 3 right angles is 270 degrees. So the fourth angle must be also equal to 90 degrees in order to complete the sum of the angles in this quadrilateral to 360 degrees. Here, this angle must be also equal to 90 degrees according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. Okay, so actually, so here we will focus on the right triangle PBM. Okay, we'll focus on the right triangle PBM. on the right triangle, triangle PBM, according to the Pythagoras theorem. So we define, first of all, side BT as A, and we define side PT as B. So we implement the Pythagoras theorem on the right triangle, triangle PBT. In the right triangle, triangle PBT, according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. By PT is the relation for Pythagoras theorem. So in the right triangle, triangle PBT, this right triangle, PB square equals to BT square plus PT square. I'll repeat again. In the right triangle, triangle PBT, according to the Pythagoras theorem, we'll get that PB square equals to BT square plus PT square. Okay, so here PB square, PB equals to 3 according to what is given as the question. So PB square is 3 squared, that is 9, and it is equal to BT square. BT is 8, therefore BT square will be equal to A square plus PT square. PT is B, therefore PT square is B square. So in total, in conclusion, I found out that according to equation number 1, A square plus B square equals to 9. Okay. So here we will focus on the lower side of line segment AT at point B. Here, this angle equals to 90 degrees. This angle is also equals to 90 degrees. 90 degrees plus 90 degrees is 180 degrees. So actually angle ABT is equal to 180 degrees. So I found out that angle ABT is equal to 180 degrees. If angle ABT is equal to 180 degrees, it means that angle ABT is a straight line, because this is exactly the definition of a straight line. So angle ABT is a straight line. Angle ABT is a straight line. If angle ABT is a straight line, it means that line segment ABT is also a straight line. Okay, line segment ABT is also a straight line. And if line segment ABT is a straight line, it means that AT is also a straight line. Okay, therefore AT is a straight line. So we know that AT is a straight line. AP, it is given us that AP, in the equation, that AP is also a straight line, and PT is part of a perpendicular that is also a straight line. Therefore, shape APT, this shape, it is actually a right triangle. I'll repeat again, shape APT is a right triangle. Shape APT is a right triangle. Therefore, we can implement the Pythagoras theorem on the right triangle, triangle APT. So on the right triangle, triangle APT, according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse is AP, therefore the square of the hypotenuse is AP squared, and it is equal to the sum of the squares of the perpendiculars. That is right, it must be equal to PT squared plus AT squared. Repeat again. According to the Pythagoras theorem, on the right triangle, triangle APT, AP square equals to PT square plus AT square. AP is equal to 5 units according to what is given as the question, therefore AP square is 5 squared, that is 25, and it is equal to PT square. PT is equal to B, therefore PT square is B square plus AT square. What is the value of AT? We define the side length of square ABCD as x, therefore all of its sides will be equal to x units in their lengths. So therefore, we get that the length of side AT is actually x plus a, is equal to x plus a. This is a, and this is x, so it is x plus a. So AT is x plus a, therefore AT squared is x plus a squared. So in conclusion, found out that according to equation number 2, 25 equals to b square plus a x plus a square. We'll open the brackets on this side of equation number 2, and we get that according to equation number 2, 25 equals to b square plus x plus a square equals to x square plus a square plus 2ax. So in equation number 1, we have a square plus b square, and according to equation number 1, we have already found out that a square plus b square equals to 9. Therefore, we can substitute a square plus b square in equation number 2 by 9. We'll do it now, and we'll get that here 25 equals to a square plus b square is 9 plus x squared plus 2ax. So in conclusion, we found out that according to equation number 2, 25 equals to 9 plus x squared plus 2ax. Here we subtract 9 from this equation, equation number 2, and we get that according to equation number 2, (25 minus 9 is 16). That is equal to x squared plus 2ax. Okay, found out that according to equation number 2, 16 equals to x squared plus 2ax. Here we subtract x squared from this equation, equation number 2, and we'll get that according to equation number 2, 16 minus x squared equals to 2ax. Here we divide this equation, equation number 2 by 2x, and we get that according to equation number 2, 16 minus x squared over 2x equals to a. So we found out the value of a. Okay, found out the value of a. So here we actually we've already found out that quadrilateral BTCN is a rectangle. Why? Because it has 4 right angles. So we write it down. Quadrilateral BTCN is a rectangle. Quadrilateral BTCN is a rectangle because it has 4 right angles. And we know that the opposite sides of a rectangle are equal to each other. That is to say, BT equals to CN. BT equals to CN. Okay, BT equals to CN according to the rule that the opposite sides of a rectangle are equal to each other. But according to our definition, BT equals to A. So we can write here that BT equals to A. And from this equation, A equals to BT equals to Cn, we derive that Cn is also equals to A. Cn equals to A. So here we found out that Cn equals to A. So we can write here that Cn equals to A. Likewise, according to the same rule that the opposite sides of a rectangle are equal to each other, we get that BC is equal to Tn. BC is equal to Tn in rectangle BC Tn. BC equals to Tn, but BC equals to x according to our definition. So we can write here that BC equals to x, and from this equation x equals to BC equals to Tn, we will derive that Tn is also equals to x. Tn is also equals to x. We can write here that Tn equals to x. In the next step, we'll implement the Pythagoras theorem on the right big triangle, triangle PCN. On the right big triangle, triangle PCN, by PT is abbreviation for Pythagoras theorem. The square of the hypotenuse, according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse is PC, therefore the square of the hypotenuse is PC squared, and it must be equal to the sum of the squares of the perpendiculars. That is to say, it must be equal to Pn squared plus Cn squared. So in conclusion, we found out that according to equation number 3, Pc squared equals to Pn squared plus Cn squared. Okay. So PC equals to 6 units according to what is given as the question. Here PC equals to 6, therefore PC squared is 6 squared, it is 36. And it is equal to Pn squared. Pn equals to B plus X. Therefore Pn squared is B plus X squared plus Cn squared. Cn is A. Therefore, Cn squared is A squared. So in conclusion, we found out that according to equation number 3, 36 equals to B plus X squared plus A squared. Here we'll open the brackets on this side of equation number 3, and we get that according to equation number 3, 36 equals to B plus X squared equals to B squared plus X squared plus 2 times bx plus a squared. In this equation number 3, we have a squared plus b squared. According to equation number 1, a squared plus b squared equals to 9. Therefore, we substitute a squared plus b squared in this equation number 3 by 9. So, and we get that according to equation number 3, (36) equals to b squared plus a squared is 9, plus x squared plus 2bx. It again, according to equation number 3, found out that 36 equals to 9 plus x squared plus 2bx. Here we subtract 9 for this equation number 3, and we get that according to equation number 3, 36 minus 9 is 27, and it is equal to x squared plus 2bx. Here we subtract x squared for this equation number 3, and we get that according to equation number 3, (27 minus x squared equals to 2bx). Here we divide this equation number 3 by 2x, and we get that according to equation number 3, b equals to 27 minus x squared over 2x. Actually, we have the values of a and b in terms of x, and according to equation number 1, we know that a squared plus b squared equals to 9. Therefore, we substitute a by the value that we found for a, and we substitute b by the value that we found for b. If we square it, and we will get actually that it is equal to 9. So, okay, so here, according to what we have already found out, that a equals to 16 minus x squared over 2x. And x squared is this expression squared plus b squared. b equals to 27 minus x squared over 2x, and if we square it, we get b squared. And it is equal to 9 according to equation number 1. Here we'll open the brackets of those two expressions, and we get that here 16 minus x squared is 16 squared, that is 256, plus x squared is x to the power of 4 minus 2 times 16 times x squared plus over 2x squared, that is 4x squared. So we will have the same denominator, that is 4x squared. Therefore, we can add the second equation to the first equation. The denominator is 4x squared, so we can add the numerator of the first equation to the numerator of the second expression. And we will get here that 27 minus x squared is 27 squared, that is 729, plus x squared is x to the power of 4 minus 2 times 27 is minus 54 x squared. Okay, and it is equal to 9. Okay, so here we have 256 plus 729 is 985. X squared, x to the power of 4 plus x to the power of 4 is 2 times x to the power of 4. Here we have 2 times 16 is 32. X squared minus 54 x squared. We will multiply this equation by 4x squared, and 4x squared times 9 is equal to 36 x squared. So here we subtract 36 x squared from this equation, equation number 1, and we get that 2x to the power of 4, and we have minus 40 minus, first of all we have here minus 54x squared minus 32x squared is minus 86x squared, and it is equal to plus 985. It is equal to 36x squared. Now we'll subtract 36x squared from this equation, equation number 1, and we'll get that according to equation number 1, two times x to the power of 4, and we have minus 86x squared minus 36x squared is minus 122x squared plus 985 equals to 0. Okay. So here we define z as x squared in order to get a quadratic equation. Z equals to x squared, and so we have here x to the power of 4 is, if z equals to x squared, it means that x to the power of 4 will be z squared. So it will be 2z squared minus 122, and x squared equals to z, therefore we substitute x squared by z, plus 985 is equal to 0. So here we have a quadratic equation, 2z squared minus 122z plus 985 equals to 0. And the general formula for a quadratic equation is ax squared plus bx plus c equals to 0. Here a, b, and c are the coefficients of the quadratic equation, and x is the variable that we are looking for. And we find out the value of x according to the following formula: x equals to minus b plus minus square root of b squared minus 4 times a times c over 2a. Okay. So here we will put, so here in our specific quadratic equation, the coefficient a equals to 2, the coefficient b equals to minus 122, and the coefficient c equals to 985. So we'll put the data inside the equation for x, and here x equals to z, so here z equals to minus b, b is minus 122, therefore minus b is minus 122, that is plus 122, plus minus square root of 122 square, b square is minus 122 square, minus 4 times a is 2, so minus 4 times 2 is minus 8, times c is 985, all divided by 2a. A is 2, so 2 times a is 2 times 2, that is 4. So here we get that z equals to 122 plus minus square root of 122 square is equal to 14,884 minus 8 times 985 is equal to 7,880 over 4. So here we get that z equals to 122 plus minus and 14,884 minus 7,880 is 7,004. So under the root we have only 7,004 over 4. So here we get that z equals to 122 plus minus and the square root of 7,004 is actually 83.6899 over 4. So here we have two solutions that are possible for z. The first solution for z is that z equals to 122 plus 83.6899 over 4. Okay. And so z equals to 122 plus 83.6899 is equal to 205.6899 over 4. So if we divide it by 4, we get that z equals to 51.4224. So z, according to our definition, is equal to x squared, and it is equal to 51.4224. So in order to find out the value of x itself, we take a root out of this equation and we get that x equals to the square root of 51.4224. That is to say, it is equal to 7, x equals to 7.1 units. Okay, but here x, it is impossible that x equals to 7.17 units. I will explain why. So here, if you focus on the right triangle, triangle APT, this right triangle, in this right triangle, the hypotenuse AP is equal to 5 units. So I write it down. The hypotenuse AP is equal to 5 units. And we know that the hypotenuse is the biggest side in any right angle. So therefore AP, hypotenuse AP is greater than AT. Again, the hypotenuse AP is greater than AT in triangle APT. So if it is greater than AT, let alone it is greater than AB. So here the hypotenuse AP is greater than AB, but AB, according to our definition, equals to x. That is to say, from this equation, 5 equals to AP, that is greater than AB, that is equal to x. We will get that x actually must be smaller than 5 units. But according to what we found here, that is that x equals to 7.17 units, that is greater than 5 units. We have a contradiction, so so this solution is incorrect solution. We cancel the solution, so we left only the second solution, that z equals to z equals to 122 minus 83.6899 over 4. So z equals to 122 minus 83 minus 83.6899, then 122 minus 83.6899 is equal to 38.3101, and if we divide it by 4, we get that z equals to 9.5775. And we know that z, according to our definition, is equal to x squared. Z equals to x squared. But what is x squared? X squared is exactly the area of square ABCD. So we actually found out that the area of square ABCD, that is equal actually to x squared, that is equal to z, it is equal to 9.5775 square units. And if we take the root of x squared, we get x, and we get that the value of x itself is equal to 309 units, and it is less than 5 units. That is to say, we know that the hypotenuse AP, that is equal to 5 units, is greater than x, that is equal to 3.09 units. Therefore, it is exactly to what we see in the drawing. So, in conclusion, we found out that the area of this square ABCD equals to 9.5775 square units, a little bit less than 10 square units. So we finished with the first question. In the next step I present to you the second question. So in the drawing we have a right triangle. Triangle ABC is a right triangle. Inside the right triangle, triangle ABC, we have a circle, and our mission is to find out the size of this angle, angle theta. And we also know that line segment AD equals to line segment EC, and DE is twice as long as AD, and DE is also twice as long as AC. And we want to find out the size of this angle, angle theta. Okay? So here, first of all, we'll define DE as 2A. Here, DE equals to 2A according to our definition. And here we have the equation that AD equals to CE, and it is equal to DE over 2. So I copied what is given as the question. Here AD equals to CE equals to D over 2. D equals to 2A according to our definition, so we substitute DE by 2A over 2. So here 2 over 2 is 1, so 2 will get cancelled. So in conclusion we found out that AD equals to CE equals to A. So you can write here that AD equals to A, and CE is also equals to A, according to what we just right now found out. Okay, so here we have also rule number 4. According to rule number 4, the perpendicular from the center of a circle to a chord bisect the chord. We have the center of the circle that is point O. From point O we draw perpendicular OM to chord CD, and according to this rule number 4, the perpendicular OM bisect chord CD. That is to say CM equals to MD. So if it bisects chord CD, it means that it divides it to two halves. That is to say, the first half, that is CD over 2, is equal to CM, and the second half, that is also CD over 2, it will be equal to MD. So I can implement rule number 4 in our drawing. From point O, we will draw perpendicular on chord DE. Okay. So this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. Okay, we'll define the touching point of the perpendicular from point O and chord DE as T. Okay, so it is equal to T. So here, according to rule number 4, the perpendicular OT bisect chord DE. That is to say, DT is the first half of DE. DT equals to DE over 2, and TE is the second half of DE. So here, TE is also equals to DE over 2. But according to our definition, DE equals to 2A, so we can substitute DE by 2A. Here we have 2 in the numerator, 2 in the denominator, so 2 will get cancelled. So here we found out that TE equals to DT equals to A. So TE equals to A and DT equals to A. Okay? In the next step, we will define the touching point of tangent AB with this circle as point M. We will define the touching point of tangent BC with this circle as point N. We will join points O and N together by a straight line. Point O is the center of the circle. Point N is the point of the circle itself. Therefore, ON is the radius of the circle that we define as R. Here we have the radius ON that is 1 to the point of tendency. Therefore, according to rule number 1, this angle equals to 90 degrees and this angle will be also equal to 90 degrees. Likewise, we join points O and M together by a straight line. Remind you that M is the point of tendency. So point O is the center of the circle. Point M is the point of the circle itself. Therefore, OM is the radius of the circle, that is R. So here we have the radius OM that is 1 to the point of tendency. Therefore, according to rule number 1, this angle equals to 90 degrees and this angle will be also equal to 90 degrees. Okay, so actually inside quadrilateral MBNO, we have 1, 2, 3 right angles. The sum of 3 right angles is 270 degrees, so the fourth angle must be equal also to 90 degrees in order to complete the sum of the angles in quadrilateral MOBN to 360 degrees. This angle must be equal to 90 degrees. So here inside quadrilateral MOBN we have 4 right angles. Therefore, we will relate to quadrilateral MOBN as a rectangle. And write it down. Quadrilateral MOBN is a rectangle. Why? Because it has 4 right angles. Quadrilateral MOBN is a rectangle. And we know that the opposite sides of a rectangle are equal to each other. That is to say, MO equals to BN. MO equals to BN. Okay, MO equals to BN. Here. So here, but MO equals to R. So we can write here that MO equals to R. And from this equation, R equals to MO equals to BN, we will derive that BN is also equals to R. Bn equals to R, so we can write here that Bn equals to R. Bn equals to R. Likewise, according to the same rule that the opposite sides of a rectangle are equal to each other, we get that ON equals to MB. Here, ON equals to MB. ON equals to MB. But we know that ON equals to R, it is the radius of the circle, so we can write here ON equals to R, And from this equation, r equals to n equals to mb, we derive that mb is also equals to r. mb is equal to r. So we actually found out that quadrilateral MOBN is not a rectangle but a square because all of its sides are equal to r. So if you find out that quadrilateral MOBN is a square. Okay? So in the next step, I will present to you a new rule that will be rule number 10. Okay? According to rule number 10, we have here a circle and we have the external point P. From the external point P, we have tangent PA to this circle that is tangent to this circle at point N, and we have the straight line that intersects with the circle at 2 points B and C. And according to rule number 10, the following equation is true, that AP square, that is the square of the tangent, equals to PB times PC. Again, AP square equals to PB times PC. Actually, we can implement rule number 10 in our drawing, because in our drawing, if we focus on the external point C, we have tangent CN, and we have this straight line that intersects with the circle at point E and at point D. So here, according to rule number 10, if we focus on the external point C, we get that Cn square, that is the square of the tangent, equals to CE times CD. Repeat again, the external point C, according to rule number 10, Cn square equals to CE times CD. So Cn square equals to CE equals to A, therefore we will substitute CE by A times CD. CD equals to A plus A plus A, that is 3A. So substitute CD by 3A. So A times 3A is 3A squared. So in conclusion, we found out that Cn squared equals to 3A squared. So we take out of this equation and we get that Cn equals to square root of 3 times A. So we found out that Cn equals to the square root of 3 times A. And right here in the drawing, that Cn equals to square root of 3 times A. Likewise, we'll focus on the external point A. From the external point A, we have tangent AM, and we have the straight line that intersects with this circle at 2 points D and E. Therefore, we can implement rule number 10 in our drawing, and we'll get that according to rule number 10, AM squared equals to AD times AE. Okay, I repeat again, according to rule number 10, the external point is point A, AM squared equals to AD times AE. So AM squared equals to AD, AD is A, so we substitute AD by A times AE. AE equals to A plus A plus A, that is 3A. So we substitute A by 3A and we get that in total AM squared equals to A times 3A, that is 3A squared. So I found out that AM squared equals to 3A squared. Here we take a root out of this equation and we get that AM equals to the square root of 3 times A. AM equals to the square root of 3 times A. Here we can write down that AM equals to the square root of 3 times A. In the next step, I will copy triangle ABC in a new page and we will analyze triangle ABC. Triangle ABC is a right triangle, so angle ABC equals to 90 degrees. We found out that side AB equals to the square root of 3 times A plus R. And actually, side BC is also equals to the square root of 3 times A plus R. So this is actually the right triangle, triangle ABC, that I copied from the original drawing. In this triangle, triangle ABC, those two sides are equal to each other. They are both equal to square root of 3 times A plus R. And we have the rule that in front of equal sides in the triangle, there are equal angles. So those two angles that are located in front of equal sides, they must be also equal to each other. So if we define this angle as theta, then this angle must be also equal to theta because of the fact that they are equal to each other. Okay, and what is the sum of those two angles? If this angle equals to 90 degrees, the sum of the other two angles must be also equal to 90 degrees because 90 degrees plus 90 degrees is 180 degrees. So in conclusion, we found out that theta plus theta must be equal to 90 degrees. Theta plus theta is 2 theta, so 2 theta must be equal to 90 degrees. We divide this equation by 2 and we get that theta equals to 90 degrees over 2 is 45 degrees. So we found out that angle theta equals to 45 degrees. So we can write down that angle theta equals to 45 degrees. Okay. Therefore, we have here a right triangle that is also an isosceles triangle. Okay. So in the right triangle, triangle ABC, it is very easy to see from the drawing that cosine 45 degrees equals to BC over AC. Again, cosine 45 degrees equals to BC over AC. So I write it down. Cosine 45 degrees equals to BC over AC. And BC equals to square root of 3 times A plus R. What is the value of AC? It is very easy to see from the drawing that the hypotenuse of AC equals to A plus A plus A plus A, that is 4A. So we substitute AC by 4A. And cosine 45 degrees is 1 over square root of 2. So we substitute cosine 45 degrees by 1 over square root of 3 over 2. And it is equal to square root of 3 times A plus R over 4A. Here we will multiply this equation by 4A, and we get that 4A over square root of 2 equals to square root of 3 plus R. Here we substitute 4 by 2 times 2, so 2 times 2 times A over square root of 2 equals to square root of 3 plus R. In the next step, we substitute 2 by square root of 2 times square root of 2, and we'll get that so it is 2 times 2, and we substitute 2 by square root of 2 times square root of 2 over square root of 2 times A equals to square root of 3 times A plus R. Okay. We have square root of 2 in the numerator and square root of 2 in the denominator, so square root of 2 will get cancelled. In total we got that 2 times square root of 2 times A plus square root of 2 is actually, it is equal to square root of 2 times A plus R. Here we substitute square root of 3 minus A from this equation, and we get that 2 times square root of 2 times A minus square root of 3 times A equals to R. So here we take A as a common factor from those two expressions. A, so what is left from 2 times square root of 2 times A after we took from it A as a common factor? What is left is actually 2 times square root of 2. And what is left for minus square root of 2 times A after we took from it A as a common factor? What is left is actually minus square root of 3, that is equal to R. So in conclusion, we found out that the value of the radius of the circle is equal to A times square root of 2 times 2 minus square root of 3. Okay, so in the next step, I will copy the right green triangle DOT in a new page, and we analyze triangle DOT. So we have triangle DOT or DTO. This is a right triangle, of course. Here, point O is the center of the circle, point D is the point of the circle itself, therefore OD is the radius of the circle, that is equal to R. dt equals to A. So this is actually the right triangle DOT, the right green triangle DOT that I copied from the original drawing. In the right triangle DOT, it is very easy to see from the drawing that cosine theta equals to dt over dO. Again, cosine theta equals to dt over dO. This angle is a right angle. Is equal to 90 degrees. So here cosine theta equals to dt over dO. dt equals to a, so we substitute dt by a over dO. dO equals to r, so we substitute dO by r. So cosine theta equals to a over r. And we already found out that r equals to a times 2 times square root of 2 minus square root of 3. Here we have a in the numerator and a in the denominator, so a will get cancelled. So in conclusion, we found out that cosine theta is equal to 1 over 2 times square root of 2 minus square root of 3. Okay, and our mission is to find out the value of theta itself. In order to find out the value of theta itself, we will operate the opposite function of cosine, that is cosine minus 1 on the result, and we will get the value of theta. So the opposite function of cosine is cosine minus 1. We will operate it on the result, that is 1 over 2 times square root of 2 minus square root of 3, and we get the value of theta. And here cosine minus 1, if we operate it on the 1 over 2 times square root of 2 minus square root of 3, we get that theta itself is equal to 24.203 degrees. So the answer to the question that the value of the size of angle theta is equal to 24.203 degrees. And again, the value of this angle theta, is equal to 24.203 degrees. We finished with the first question. In the next step, I will summarize the lecture. We start with the first question, of course. So in the drawing, we have square ABCD, this square, and we know that AP, line segment AP equals to 5 units, line segment BP equals to 3 units, line segment PC equals to 6 units, and our mission is to find out the area of this square ABCD. Okay, so first of all we did the construction. We extended side DC of the square by a straight line, and from point P we drew perpendicular on the extended DC. So this angle equals to 90 degrees and this angle also equals to 90 degrees according to our construction. Then from point B we drew perpendicular on PN. Again, from point B, we do perpendicular on PN. Therefore, this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point B and P and ST, and we define the touching point of the perpendicular from point B and the extended DC as N. Okay? So here we defined side PT as B and side BA as A. Then we focused on the right triangle PBT, on the right triangle PBT according to the Pythagoras theorem. PB square equals to PT square plus BT square. Repeat again, in the right triangle PBT, according to the Pythagoras theorem, PB square equals to BT square plus PT square. So here PB is 3, therefore PB square is 3 squared, that is 9. And it is equal to BT square. BT is A, therefore BT square is A squared, plus PT square. PT is B, therefore PT square is B squared. So in conclusion, we found out that according to equation number 1, A square plus B square equals to 9. Okay. So here we know that all the angles inside the square are right angles, so those angles are right angles. And this angle equals to 90 degrees according to our construction. This angle equals to 90 degrees according to our construction. And here, side DC of the square is a straight line. And when we extended the straight line DC by a straight line, the result is dn, that is must be also a straight line, because when you extend a straight line by a straight line, the result must be a straight line. So dn is a straight line. So if we focus on the upper side of the straight line dn at point C, the sum of the angles must be equal to 180 degrees, according to rule number 3, that the sum of the angles on one side of a straight line is equal to 180 degrees. So this angle equals to 90 degrees. So the missing angle, so if you focus on the upper side of DC at point C, we have this angle that is equal to 90 degrees plus the missing angle. In total, they must be equal to 180 degrees. Therefore, the missing angle must be also equal to 90 degrees in order to complete the sum of the angles on the upper side of the N at point C to 180 degrees. This angle must be equal to 90 degrees. So we actually found out that inside quadrilateral BTCN, we have 1, 2, 3 right angles. Therefore, the fourth angle, the sum of 3 right angles is 270 degrees. Therefore, the fourth angle must be also equal to 90 degrees. According to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. So if we have 3 angles with 270 degrees, the fourth angle must be equal to 90 degrees. In order to complete the sum of the angles in this quadrilateral to 360 degrees, this angle must be equal to 90 degrees. So we actually found out that if we focus on the lower side of segment line AT at point B, this angle equals to 90 degrees, because it is one angle inside the square that is equal to 90 degrees. And we already found out that this angle also equals to 90 degrees. 90 degrees plus 90 degrees is 180 degrees. So we actually found out that angle ABT equals to 180 degrees. And this is exactly the definition of a straight line. That is to say, angle ABT that is equal to 180 degrees must be a straight line. Repeat again, angle ABT that is equal to 180 degrees is a straight line. So if angle ABT is a straight line, it means that line segment ABT is also a straight line. And if line segment ABT is a straight line, it means that AT is also a straight line. So if I know that AT is a straight line, likewise we know that it is given us the equation that AP is also a straight line and PT is a part of a perpendicular, therefore it is also a straight line. Therefore shape PAT is a right triangle. Here shape PAT is a right triangle. Okay, here shape PAT is a right triangle. Okay, and we know, so therefore we can implement the Pythagoras theorem on the right triangle, triangle APT. According to the Pythagoras theorem, in the right triangle, triangle APT, AP square equals to PT square plus TA square. Again, AP square equals to PT square plus TA square. Fit again in the right triangle, triangle APT, AP square equals to PT square plus AT square. AP equals to 5 according to what is given as the equation, therefore AP square is 5 squared, that is 25. And it is equal to PT square. PT is B, therefore PT square is B squared plus AT square. AT equals to X plus A. Again, AT equals to X plus A, therefore AT square is X plus A squared. So in conclusion, we found out that according to equation number 2, 25 equals to B square plus 8X plus A squared. Here we open the brackets on this side of equation number 2 and found out that 25 equals to B square plus X plus A square equals to X square plus A square plus 2 times AX. Okay, so here in equation number 2 we have A square plus B square, so we can substitute A square plus B square by 9, because according to equation number 1, A square plus B square equals to 9. So we did it, and we got that 25 equals to A square plus B square is 9, plus X square plus 2AX. We subtracted 9 from this equation, equation number 1, and found out that 25 minus 9 is 16. So in total we found out that according to equation number 2, 16 equals to X squared plus 2AX. Here we subtracted X squared from this equation, equation number 2, and found out that according to equation number 2, 16 minus X squared equals to 2AX. 2AX, here we divided this equation, equation number 2 by 2x, and found out that A equals to 16 minus X squared over 2x. Then, we have already found out that quadrilateral BTCN is a rectangle, and we know that the opposite sides of a rectangle are equal to each other. That is to say, BT equals to CN. BT equals to CN in rectangle BTCN. But according to our definition, BT equals to A. BT equals to A, therefore we can write here that BT equals to A, and from this equation A equals to BT equals to CN, we will derive that CN is also equals to A. Here CN equals to A. Then, according to the same rule that the opposite sides of a rectangle are equal to each other, we get that BC equals to TN. BC equals to TN. BC, here BC equals to TN. BC equals to TN. But according to our definition, BC equals to X, so we can write here that BC equals to X, and from this equation, X equals to BC equals to Tn, we derive that Tn is also equals to X. Here Tn equals to X. Then we implemented the Pythagoras theorem on the right big triangle, triangle PCN. On the right big triangle, triangle PCN, PC square equals to PN square plus CN square. Again, PC square equals to PN square plus CN square. PC equals to 6 according to what is given as the equation, therefore PC square is 6 squared, that is 36, and it is equal to Pn square. Pn equals to B plus X. Therefore Pn square equals to B plus X square plus Cn square. Cn equals to A, therefore Cn square equals to A square. So in conclusion, we found out that 36 equals to B plus X square plus A square. Here we open the brackets on this side of equation number 3, and found out that according to equation number 3, 36 equals to B plus X square equals to B square plus X square plus 2 times Px plus A square. Here, in equation number 3, we have a squared plus b squared, therefore we can substitute a squared plus b squared by 9 according to equation number 1. We did it, and we got that according to equation number 3, 36 equals to 9 plus x squared plus 2bx. Here we subtracted 9 from this equation number 3, and found out that 36 minus 9 is 27, so 27 equals to x squared plus 2bx. Here we subtracted x from this equation number 3, and found out that the equation, according to equation number 3, 27 minus x squared equals to 2bx. Here we divided this equation number 3 by 2x, and we found out that according to equation number 3, b equals to 27 minus x squared over 2x. So we actually have the values of a and b in terms of x. And according to equation number 3, we know that a squared plus b squared equals to 9, therefore we can substitute a by the value that we found for a, and substitute b by the value that we found for b. Here we did it here, and we found out that according to equation number 1, a is 16 minus x squared over 2x, therefore a squared is 16 minus x squared over 2x squared plus b squared. B is 27 minus x squared over 2x, therefore b squared is 27 minus x squared over 2x squared, and it is equal to 9. Here we open the brackets on this side of equation number 1, and we found out that according to equation number 1, 16 minus x squared equals to 16 squared, that is 256, plus x squared is x to the power of 4 minus 2 times 16 times x squared over 2x squared, that is 4x squared. So here the denominator of those two expressions are the same, it is 4x squared, so we can add this numerator to this numerator because they have the same denominator. So here 27 minus x squared equals to 27 squared, that is 729, minus x plus x squared is x to the power of 4 minus 2 times 27 times x squared, that is minus 54x squared, all divided by 4x squared, that is equal to 9. Here 256 plus 729 is 985, x to the power of 4 plus x to the power of 4 is 2 times x to the power of 4. Here 2 times 16 x squared is 32x squared, and minus 54x squared equals to, here we multiplied this equation number 1 by 4x squared, and 9 times 4x squared is 36x squared. Okay, then we subtracted 36x squared from the equation number 1, and found out that 2x to the power of 4, and here we have minus 32x squared minus 54x squared is minus 86x squared plus 985. Now we've subtracted 36x squared from this equation number 1, and found out that according to equation number 1, two times x to the power of 4, and we have minus 86x squared minus 36x squared is minus 122x squared plus 985 equals to 0. Okay, then we defined as x squared as z, and here if x squared equals to z, it means that x to the power of 4 will be equal to z squared. So we substitute x to the power of 4 by xz squared. So 2x to the power of 4 is 2z squared minus 122, and z equals to x squared, so we substitute x squared by z plus 985. So we got the quadratic equation that 2z squared minus 122z plus 985 equals to 0. And the general formula for quadratic equation is ax squared plus bx plus c equals to 0. and A, B, and C are the coefficients of the quadratic equation, and x is the variable that we are looking for. And we find out the value of x according to the following formula: x equals to minus b plus minus square root of b squared minus 4 times ac over 2a. In our specific quadratic equation, the coefficient a equals to 2, the coefficient b equals to minus 122, and the coefficient c equals to 985. So we put the data inside the formula for x, and we found out the value of the values of z, because z equals to x. So we get that z equals to minus b equals to minus 122, therefore minus b is 122 plus minus square root of b squared. B is minus 122, therefore the square is minus 122 squared, minus 4 times a. A is 2, so minus 4 times 2 is minus 8, times c is 925, therefore minus 4 times ac is minus 8 times 985 over 2a. A is 2, so 2 times 2 is 4. So z equals to 122 plus minus 122 square is 14,884, minus 8 times 985 is minus 7,880, all divided by 4. So here z equals to 122 plus minus 14,844 minus 7,880 is 7,004, all divided by 4. And the square root of 7,004 is equal to 83.6899. So in conclusion, we have two solutions for z. Z equals to 122 plus minus 83.6899 over 4. So z equals to 120. So according to the first solution, z equals to 122 plus 83.6899 over 4. 122 plus 83.6899 is 205.6899, and if we divide it by 4, we get that z equals to 51.4224. So if z equals to x squared, so if we take the root from z, we get the value of x itself. X squared equals to 51.4224, therefore x itself will be equal to the square root of 51.4224, that is to say x equals to 7.17. But here it is impossible that x equals to 7.17, because if you focus on the right triangle APT, the hypotenuse AP equals to 5 units. And AB, that is x, is part of side AT. And we know that the hypotenuse is the biggest side in any right triangle. Therefore, AP must be greater than AB. Here, AP, that is equal to 5, must be greater than AB, that is equal to x. So from this equation, 5 equals to AB, that is greater than AB equals to x, we derive that x must be less than 5 units. But here we found out that x is equals to 7.17, that is greater than 5 units. So we have a contradiction, therefore we cancel the solution, and we left only with the second solution. According to the second solution, z equals to 122 minus 83.6899 over 4. 122 minus 83.6899 is 33.3101, and if we divide it by 4, we get that z equals to 9.5775. So z equals to x squared, and x squared is exactly the area of triangle ABC. That is to say, the area of triangle ABC that is equal to x squared, that is equal to z, will be equal to 9.5775 square units. And if we take the root from x squared, we get that x, and we get that x equals to the square root of 9.5775, that is equal to 3.09. That is less than 5 units. That is to say, the hypotenuse AP is greater than AB. Okay, because x equals to 3.09 units. Okay, so in conclusion, found out the area of triangle ABC equals to 9.5775 square units. We finished with the first question, then I presented to you the second question. So here in the drawing we have the right triangle, triangle ABC. Inside the right triangle ABC we have a circle. We know that AD equals to EC and DE is twice as long as AD and also twice as long as EC. Here AD equals to CE, AD equals to CE, and DE is twice as long as EC and AD. And our mission is to find out the value of the size of this angle, angle theta. Okay, so first of all we defined DE as 2A. Here DE equals to 2A according to our definition, and we have the equation that is given us the equation that AD equals to CE equals to DE over 2. DE equals to 2A according to our definition, so we substitute DE by 2A and we got that here it is it is 2A over 2. We have 2 in the denominator, 2 in the denominator, so 2 will get cancelled. In conclusion, we found out that AD equals to CE equals to A. So here AD equals to A and CE equals to A. Then I presented to you rule number 4. According to rule number 4, we have according to rule number 4, the perpendicular from the center of a circle to a chord bisect the chord. Here, from point O, that is the center of the circle, we have a perpendicular OM. The perpendicular OM bisect chord CD, that is to say CM equals to MD equals to CD over 2. You can implement rule number 2 in our rule number 4 in our drawing. We draw perpendicular from point O on chord DE, so this angle equals to 90 degrees and this angle equals to 90 degrees according to our construction. And here, according to rule number 4, dt equals to TE. dt equals to TE and dt equals to DE over 2 and TE also equals to DE over 2 because the perpendicular bisects DE into 2 halves. Each half equals to DE over 2. Okay, TE equals to DT equals to D over 2. But D equals to 2A according to our definition. So here we have 2 in the numerator and 2 in the denominator, so 2 will get cancelled. So in conclusion, we found out that TE equals to DT equals to A. That is to say, here dt equals to A and TE is also equals to A. Okay, then we define the center of, we define the point of tendency of tangent AB with this circle as M. We define the point of tendency of tangent BC with this circle as M. We join points O and M together by a straight line. Point O is the center of the circle, point M is the point of the circle itself, therefore OM is the radius of the circle that is equal to R. We have the radius OM that is drawn to the point of tendency, therefore according to rule number 1, this angle equals to 90 degrees and this angle also equals to 90 degrees. Likewise, we join points O and M together by a straight line. Point O is the center of the circle, point M is the point of the circle itself, therefore ON is the radius of the circle that is equal to R. So we have the radius ON that is 1 to the point of tendency, therefore according to rule number 1, this angle equals to 90 degrees and this angle equals to 90 degrees. So here inside quadrangle MOBN, we have 1, 2, 3 right angles that are equal to 270 degrees. Therefore, the fourth angle must be also equal to 90 degrees, according to the rule that the sum of the angles in any quadrangle is equal to 360 degrees. So quadrangle MOBN is 4 right angles. Therefore, quadrangle MOBN is a rectangle, and we know that the opposite sides of a rectangle are equal to each other. That is to say, MO equals to BN. MO equals to BN, but here MO equals to R. We know that MO equals to R, so we can write here that MO equals to R, and from this equation R equals to MO equals to BN, we derive that BN is also equals to R. Here BN is also equals to R. Likewise, according to the same rule that the opposite sides of a rectangle are equal to each other, we get that MB equals to ON. MB equals to ON, but we know that ON equals to R. ON equals to R, and from this equation R equals to ON equals to BM, we derive that BM is also equals to R. So we found out that all the sides of quadrangle MOBN are equal to each other, therefore quadrangle MOBN is a square. Okay, then I presented to you rule number 10, and we implemented rule number 10 in our drawing. According to rule number 10, if we have this circle and we have the external point P, from the external point P we have tangent PA, this is tangent to the circle at point N, at point A, and we have the straight line from P that intersects with the circle at point B and at point C. According to rule number 10, the following equation is true that PA square equals to PB times PC. Again, PA square equals to PB times PC. We can implement rule number 10 in our drawing, because if we focus on our drawing at the external point C, we have tangent CN and the straight line that intersects with the circle at point E and at point D. Therefore, according to rule number 10, we get that Cn square equals to Ce times Cd. Again, Cn square equals to Ce times Cd. Repeat again, at point C, Cn square equals to Ce times Cd. So Cn square equals to Ce. Ce is A, so we substitute Ce by A times Cd. Cd equals to A plus A plus A, that is 3A. So we substitute Cd by 3A. In conclusion, we found out that Cn square equals to A times 3A is 3A square. So Cn square equals to 3A square. We took a root out of this equation and found out that Cn equals to the square root of 3A. Here Cn equals to the square root of 3A. Then we focused on the external point A. We implemented rule number 10 here. We have tangent AM and the straight line from point A intersect with the circle at point D and at point E. Therefore, we can implement rule number 10 in our drawing. According to rule number 10, AM square equals to AD times AE. Again, AM square equals to AD times AE. Repeat again. Here, at point A, according to rule number 10, AM square equals to AD times AE. So AM square equals to AD. AD is A, so substitute AD by A times AE. AE equals to A plus A plus A, that is 3A. So substitute AB by 3A, and we found out that AM equals to A times 3A, that is 3A squared. Then we took a root out of this equation and found out that AM equals to the square root of 3A. So we can write here that AM equals to the square root of 3A. Then I copied the right triangle ABC, and we analyze triangle ABC. In the right triangle ABC, AB equals to square root of 3 times A plus R. And the BC also equals to square root of 3 times A plus R. Okay, so we have those two sides, they are both equal to square root of 3 plus 8, square root of 3 times A plus R, therefore they are equal to each other. And we have the rule that in front of equal sides in the triangle, there are equal angles. So in front of those two sides, we have those two angles, therefore they are equal to each other. So if this angle is theta, then this angle must be also equal to theta. And we know that the sum of those two angles must be equal to 90 degrees. Why? Because this angle is 90 degrees, and 90 degrees plus 90 degrees is 180 degrees. That is to say, theta plus theta must be equal to 90 degrees. Theta plus theta is 2 theta, and 2 theta equals to 90 degrees. We divided this equation by 2 and found out that theta equals to 90 degrees over 2 is 45 degrees. So we found out that this angle theta equals to 45 degrees. Therefore, we have here a right triangle that is an isosceles triangle also. So we focus on the right triangle, triangle ABC, that is an isosceles triangle also. In the right triangle, triangle ABC, we know that cosine 45 degrees equals to BC over AC. Again, cosine 45 degrees equals to BC over AC. BC equals to square root of 3 times A plus R. Substitute BC by square root of 3 times A plus R. AC, what is the value of AC? The hypotenuse AC equals to A plus A plus A plus A, that is 4A. So we substitute AC by 4A. We know that cosine 45 degrees equals to 1 over square root of 2. Substitute cosine 45 degrees by 1 over square root of 2. So in conclusion, we found that 1 over square root of 2 equals to square root of 3 times A plus R over 4A. Here we multiply this equation by 4A, and we found out that 4A over square root of 2 equals to square root of 2 times A plus R. We substituted 4 by 2 times 2, and we got that 2 times 2 times A over square root of 2 equals to square root of 3 times A plus R. Then we substituted 2 by square root of 2 times square root of 2. And we got here, we have 2, and we substituted the other 2 by square root of 2 by times square root of 2 over square root of 2 times A plus square root of 2 times A, that is equal, times A equals to square root of 2 times A plus R. We have square root of 2 in the numerator and the square root of 2 in the denominator, so square root of 2 will get cancelled. So in conclusion, we found out that this expression equals to 2 times square root of 2 times A, and it is equal to square root of 2 times A plus R. Here we subtracted square root of 2 times A from this equation and found out that 2 times square root of 2 times A minus square root of 2 times A equals to R. Then we took a second factor out of this out of those two expressions. So here, what is left from 2 times square root of 2 times A after we took from it A second factor? What is left? It is actually square root of 2 times 2. What is left from minus square root of 3 times A after we took from it A second factor? What is left? It is actually minus square root of 3. So in total, we found out that in conclusion, we found out that A times 2 times square root of 2 minus square root of 3 equals to R. Then I copied triangle, the green triangle OTC in the new page, and we analyze triangle OTC. Here, DT is the radius of the circle, and all DT equals to R, and DO equals to R, because O is the center of the circle, and D is the point of the circle itself, therefore DO equals to R. DT equals to A, so here DO equals to R and DT equals to A. This angle equals to 90 degrees, and this angle, the angle that we are looking for, equals to theta. According to this, in the right triangle, triangle DOT, it is very easy to see that cosine theta equals to dt over do. Cosine theta equals to dt over do. Here, cosine theta equals to dt over do. It is very easy to see it. Cosine theta equals to dt over do. Okay. so dt equals to a, so we substitute dt by a. dO equals to r, we substitute dO by r. And we found out that cosine theta equals to a over r. And we already found out that r equals to a times times 2 times square root of 2 minus square root of 3. So we substitute r by a times 2 times square root of 2 minus square root of 3. So we have a in the denominator and a in the numerator and a in the denominator, so a will get cancelled. And finally we found out that cosine theta equals to 1 over 2 times square root of 2 minus square root of 3. And our mission is to find out the value of theta itself. So in order to find out the value of theta itself, we will operate the opposite function of cosine, that is cosine minus 1, on the result. In this way we will get the value of theta. So we operated the opposite function of cosine, that is cosine minus 1, on the results. That is 1 over 2 times square root of 2 minus square root of 3. And we got the result is theta. Okay, and we know that the opposite function, if we operate it on the result, that is 1 over 2 times square root of 2 minus square root of 3, will give us the value of theta, and the value of this expression is equal to 24.203 degrees. So in conclusion, we found out the size of angle theta is equal to 24.203 degrees. Here the size of this angle theta is equal to 24.203 degrees. Okay? Thank you very much.